The Sun, Features and Activities, Part 1 of 2. Sun's rainbow of wavelengths. Taking a photo of the Sun with a standard camera will provide a familiar image, a yellowish, featureless disk, perhaps colored a bit more red when near the horizon since the light must travel through more of Earth's atmosphere and consequently loses blue wavelengths before getting to the camera's lens. The Sun, in fact, emits light in all colors, but since yellow is the brightest wavelength from the Sun, that is the color we see with our naked eye. When all the visible colors are summed together, scientists call this white light. Specialized instruments, either in ground-based or space-based telescopes, however, can observe light far beyond the ranges visible to the naked eye. Different wavelengths convey information about different components of the Sun's surface and atmosphere, so scientists use them to paint a full picture of our constantly changing and varying star. This animation, created by NASA's Scientific Visualization Studio at NASA's Goddard Space Flight Center, shows how features of the Sun can appear dramatically different when viewed in different wavelengths. This shows how observations of the Sun in different wavelengths helps highlight different aspects of the Sun's surface and atmosphere. Solar activity. The Sun is a magnetic variable star that fluctuates on time scales ranging from a fraction of a second to billions of years. Solar flares, coronal mass ejections, high-speed solar wind, and solar energetic particles are all forms of solar activity. All solar activity is driven by the solar magnetic field. Solar activity or Sun feature can release huge amounts of energy in particles, some of which impact us here on Earth. Much like weather on Earth, conditions in space, known as space weather, are always changing with the Sun's activity. Space weather can interfere with satellites, GPS, and radio communications. It also can cripple power grids and corrode pipelines that carry oil and gas. Some aspects of the Sun's activity and influence are well understood by scientists, while others remain under study. Here are some definitions of common things that occur on the Sun or are driven by the Sun's influence. Sun activities and/or features. Shown in diagram. Coronal hole. Coronal mass ejection or CME. Coronal or plasma rain. Filament or prominence. Flux rope. Not shown in diagram. Alfvén surface or zone. Alfvén surface or Alfvén zone. The Alfvén surface, or zone, is the point past which material leaving the Sun is moving too quickly for its influence to propagate back to the Sun itself. The Alfvén surface marks the transition point between the Sun's outer atmosphere, the corona, and the solar wind. As material leaves the Sun, in the form of solar wind or explosive clouds called coronal mass ejections, it accelerates, eventually pushing its speed past the maximum speed of an Alfvén wave, a type of plasma wave. If the material is moving away from the Sun faster than this top plasma wave speed, any disturbances produced in the material itself can no longer travel backwards towards the Sun. Current measurements have not yet been able to pinpoint the exact distance of the Alfvén surface from the Sun. Artist impression of the boundary between the corona and the solar wind called Alfvén surface or zone, including the Parker Solar Probe orbit path. Coronal or plasma rain. Corona or plasma rain is made of giant globs of plasma that drip from the Sun's outer atmosphere back to its surface. It occurs when particular conditions, such as magnetic field line configurations and local heating events in the corona, cause the plasma globs there to become cooler and denser than their surroundings, making them rain down. On July 19, 2012, an eruption occurred on the Sun that produced a moderately powerful solar flare and a dazzling magnetic display known as coronal rain. Hot plasma in the corona cooled and condensed along strong magnetic fields in the region. Magnetic fields are invisible, but the charged plasma is forced to move along the lines, showing up brightly in the extreme ultraviolet wavelength of 304 angstroms and outlining the fields as it slowly falls back to the solar surface. Coronal hole. A coronal hole is a patch of the Sun's atmosphere with much lower density than elsewhere. In ultraviolet views of the Sun, coronal holes appear as dark splotches. These are regions where the Sun's magnetic field lines are connected directly to interplanetary space, allowing solar material to escape out in a high-speed stream of solar wind, leaving a dark hole near the surface of the Sun. A sample of solar coronal holes around the time of the minimum of sunspot activity, October 2019. Note the coronal holes in the solar polar regions, near the top and bottom of the solar disk, and the large coronal hole across the Sun's equator. A pair of substantial coronal holes were the most notable features on the Sun last March 28 to April 2, 2015. These were magnetically open areas out of which solar wind streams. Coronal mass ejection or CME. Coronal mass ejections or CMEs are immense clouds of magnetized particles blasted into space by the Sun at over 1 million miles per hour, often following after a solar flare. CMEs expand as they sweep through space, often measuring millions of miles across. When directed at Earth, a CME can produce geomagnetic disturbances that ignite bright auroras, short-circuit satellites, and power grids on Earth, or at their worst, even endanger astronauts in orbit. After a large sunspot rotated out of Earth's view on July 17, 2017, NASA instruments could still track its effects on the far side of the star. This imagery from NASA's Solar Terrestrial Relations Observatory on July 23, 2017, captures an eruption of solar material, a coronal mass ejection, from that same active region. The long finger sticking out of the Sun at the bottom left of this image is a coronal mass ejection. It was captured by NASA's Solar Dynamics Observatory on August 31, 2012. Filament. Filaments are strands of solar material, cooler and denser than their surroundings, suspended above the Sun by magnetic forces. They appear as dark lines when seen against the bright Sun. When solar filaments become unstable, they can either fall back onto the Sun or erupt into space, sending a coronal mass ejection away from the Sun. When a solar filament is seen at the edge of the Sun, against the blackness of space, it is called a prominence instead. Space weather forecasters keep an eye on filaments as they can be just as important as solar flares for causing space weather. Two noteworthy features were noted on the Sun: a pair of elongated filaments, September 8, 2016. The central one was twisted into the shape of an elaborate arch at the center of the Sun, yellow arrows. If this were straightened out, it would extend just about across the entire Sun, almost 1 million miles, 1.6 million kilometers. The other, smaller filament, white arrows, if made straight, might reach about half that distance. Still, pretty impressive. Filaments are elongated strands of plasma suspended above the Sun by magnetic forces. They are notoriously unstable and often break apart within a few days. The image was made by combining 3 images in different wavelengths of extreme ultraviolet light. In August 2012, a long filament of solar material coalesced in the Sun's atmosphere. For several days it was visible, appearing from Earth's viewpoint to curl up and over the left side of the Sun. Scientists estimate its length was approximately 186,000 miles, equivalent to 30 Earths placed side by side. On August 31, 2012, at 4:36 p.m. Eastern Daylight Time, the filament expanded and erupted, releasing particles into space at speeds of 900 miles per second. The ejected material did not head directly toward Earth, though some of it did glance off the planet's magnetic environment, or magnetosphere, causing aurora to appear on the night of Monday, September 3rd. The video shows the eruption, a particularly gorgeous one, even for veteran observers of the Sun, as seen by 3 NASA spacecraft. Filament eruption in multiple wavelengths. Flux rope. A flux rope is kind of a magnetic structure that is thought to be at the heart of many of the sun's eruptions. Flux ropes form in plasmas, such as the sun's corona, when loops of magnetic field lines connect with each other. The resulting flux ropes are formed from bundles of magnetic fields that have a magnetic field wrapped around them, like the stripes on a candy cane. These twisted structures extend in a series of loops from the sun's surface, and can be carried away from the sun by a coronal mass ejection. Blended 131 and 171 angstrom light view of flux rope formation and eruption.